In Lesson 11.2, we will be discussing the area of parallelograms and triangles. Similarly to Lesson 11.1, I understand that many of you have already learned the area of a parallelogram formula to be area equals base times height. Your textbook demonstrates a simple proof of this by showing a right triangle using the altitude dropped from one vertex to the opposite side can be removed and placed on the other side of your parallelogram in order to form a rectangle that has the exact same base and height as your original parallelogram, thus having the same area formula. The area of a triangle is given by the formula 1/2 base times height. You may recognize the base and height from the formula of a parallelogram. If you draw a diagonal of a parallelogram, you would be able to prove that you have two congruent triangles making up that parallelogram of height and base as given. The triangle on the left represents the same height and base as the parallelogram on the right. Therefore, the formula is 1/2 base times height. It is extremely important to note, as your book points out in example 1, that the base of a triangle is not always the bottom side. In this case, your altitude is drawn to the segment with a length of 15 centimeters. You must always locate the right angle when finding the altitude to the base. In example 1b, the altitude of the triangle is not always inside the triangle. You have to be creative when trying to find the altitude and the base. Though we will not go over every example problem from your textbook, I felt that it was very important for me to point out problem number 3 in this section. Your parallelogram is not given a height at first, but you can use the idea of a 30, 60, 90 triangle, which I've told you many times, they're not going away. So in order to find the height of this parallelogram, we must first think about our 30, 60, 90 rules, x, x root 3, and 2x, in order to continue on to find the height of your parallelogram. Similarly, we can use the formulas from section 11.1 when we were working on composite figures to realize that this trapezoid is divided into a rectangle and two right triangles. In summary, today we learned two formulas. Some of you may have felt that these formulas were familiar, but the area of a parallelogram is given as base times height. In this parallelogram, base could be this horizontal segment and height would be perpendicular to it. But there's also a possibility that we may look at the base as being this oblique segment and the height as being perpendicular to that base. Both formulas should yield the same value for your area of your parallelogram. For a triangle, there are many options for the base and the height. Most predominantly is an acute triangle, looking at the base as the horizontal segment and the height being perpendicular to it. Area is 1/2 base times height. Occasionally, you may have a triangle that has an obtuse angle, in which case the height would actually be outside of your triangle. So this little piece is not included in the base. Many students often try to add that in. Please don't fall victim to this mistake. The two example problems that I've selected today are pretty difficult problems, but they show up often during the chapter. Please pause the video now to try out the examples. When you are finished, restart the video to check your work. The main purpose of our lesson today is to be able to find the area of parallelograms and triangles. In part A of this first example, I'm asking us to find the length of the altitude to the hypotenuse of a 12, 16, 20 triangle. So if I draw this 12, 16, 20, The altitude to the hypotenuse would be this blue segment right here that I'm going to call height. Sometimes these problems are referred to as area two ways. My first step will be to find the area of the triangle using base and height given as 12 and 16. This allows us to find the area to be 1/2 times 12 times 16, which is equal to 96. Now that we know the area of the entire triangle, we can consider the base to be 20 and the height to be unknown. If we know the area already to be 96, we could set up 1/2 base times height, 1/2 times 20 times h equal to 96. This would give us 10h equals 96, and the height, or the altitude to the base, to be 9.6 units. In problem B, we are given that segment dx and segment dy are altitudes in our parallelogram. So I'm going to go ahead and put the right angles in right away. If dx has a length of 8 and segment AB has a length of 24, and the perimeter of the parallelogram is 80, we can definitely find segment dy's length, I'm going to call it height, again, like in part A, using area two ways. Knowing that the perimeter is 80 and our figure is a parallelogram, we can also find segment DC to be of length 24. If you subtract 80 minus 48, you'll be left over with 32 units to be split between segment BC and AD, making them each 16. Now that we have the basics, we can find the area of our parallelogram using the formula base times height. So if I stick with the area to be 24 times 8, I get an answer of 192 square units. Now if I consider my base and height to be two different bases and heights in the same figure, I can use the formula area equals 16 times h. But we already know the area to be 192. So if I divide 192 divided by 16, I get a height of 12, thus making the length of dy 12 units. In today's lesson, we discussed finding the area of a parallelogram to be given as area equals base times height, finding the area of a triangle to be 1/2 base times height, and we also discussed area two ways. These problems come up pretty regularly throughout the unit. During class, you will be working on some problems with your group as well as some homework problems to be turned into Schoology. Thanks for listening, and I hope you have a wonderful day.